For years, zero trust sounded important, but was optional or nice to have for many organizations. And that's because the microservices that we were building and running took a very predictable path. For example, let's say you have an application where you have a front end that talks to one or more backends. Every one of those talks to maybe a couple more downstream applications and then a database. But overall, this code path is very predictable. Given a set of inputs, it always behaves the same way because it's the same code that they're running every single time. With agentic workflows, this is fundamentally different. We have agents that are consuming one or more LLMs, and these agents require data, so they're consuming one or more MCP servers. And every one of these MCP servers, this could be privately hosted or public registry MCP servers, so every one of these is backed by one or more tools. And these agents reason about to accomplish the goal that the user asked them to do. And now we're seeing a rise of multi-agent workflows, where one agent doesn't operate just entirely by itself, but speaks to other agents, communicates with other agents to accomplish the goal. And every one of these agents is backed by their own LLMs and consumes their own set of tools. So as you can already see, agents follow a totally different communication path within one another. The network diagram looks totally different and unpredictable compared to microservices. Given the same set of user input, they behave differently on every execution. And again, that's because they reason about. This problem is often worsened when you don't have proper prompt injection and prompt guards in place. So depending on what the user input is, which can definitely change based on every single input, these agents take a different communication path. The other thing to keep in mind is identity. Even when you're enforcing security policies with microservices, it was very easy to do because every single workload just needs to have its own identity. There's a workload A identity, workload B identity, and then workload C identity, and then based on those identities, you can write policies that says A is allowed to talk to B, and B is allowed to talk to C, and A is not allowed to talk to C. You cannot do that with agentic workflows. These agents not only have their own workload identity, which might give them a lot of privileges, but that privileges needs to be scoped down based on the context of what they're trying to accomplish. More specifically, based on the identity of the user. So depending on which user is calling the agent should be allowed to do a different set of tasks. This is not only important from a policy perspective, but also observability and auditability so that you can keep track and you can audit exactly why an agent behaved the way it did for a particular user and be able to replicate any behavior and fix any code paths that you need to address. So identity and prompt injection and policy looks totally different with agentic workflows. You cannot embed the security model directly in the agents. The security model needs to be moved out of the agentic workloads and moved into the platform. And every single hop needs to be authenticated and authorized. And a policy needs to be there to make sure that communication can happen. Thankfully, we have the technology that's needed to solve these problems. We just need to augment it and improve it to fix the missing gap that's needed for agentic workflows. At the core of it, running these agents or MCP servers on Kubernetes allows you to deploy them as units that Kubernetes can schedule, can scale across one or more clusters and move these workloads and treat them as units. For the identity of every single piece, we will leverage a service mesh. So we can use Istio to provide the strong identity that's needed for every one of these agents and MCP servers. To enforce policy on every one of these communication hops, we need a new type of proxy. And this proxy needs to be able to understand the new agentic workflows. It needs to be able to understand calling LLMs and how to reason about the context. It needs to be able to understand calling MCP servers. And that proxy is Agent Gateway. So Agent Gateway is a new AI proxy specifically designed to be able to enforce policy, whether that's user to agent, agent to agent, or agent to MCP, or LLM consumption. All of those use cases are in Agent Gateway. But this is just the proxy. So you run your workload on Kubernetes. The identity is provided by Istio. And Istio, on every network hop, will transparently route traffic through Agent Gateway. So there's an Agent Gateway here, 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 and here. On every single path, we're routing through an Agent Gateway, and Agent Gateway enforces the policy. So AI didn't create these security problems. It just removed the shortcuts. Previously, you were able to get away from not enforcing these because we had a very predictable communication paths. With agentic workflows, that's changed. Thankfully, we do have the proper stack that's ready to go. We just need to make sure that we're running all of this on the proper stack and we're not taking any shortcuts.